guys, so today we will see how to implement a queue using a linked list. Here we are using first in first out approach. What is first in first out? Whatever comes first in the queue, it just goes out first in the queue. I will just repeat it again. Whatever comes first in the queue goes out first in the queue. For example, here I took it's a kind of linked list only, so we can see it like a linked list. So here we are having three nodes, 1, 2 and 3. Here for Enqueue, or otherwise in stack we call it as push operation, in queue we call it as Enqueue. In queue we call the insertion operation as Enqueue and then deletion operation as DQ. Okay, so these words are very important here. So in queue insertion we call it as Enqueue and then deletion we call it as DQ. So here it uses insertion at tail approach in linked list. In linked list we use insertion at tail. So that approach we are going to use to implement Enqueue operation in queue. So which means that I'm having only one node. If I'm inserting the second node 2, then it will get added to the next. If I'm inserting 3, then it will add it to the next. So the first node we call it as front or first. We call the first node as front or first and the last node as rear or last. So for example, in the first iteration, if I'm having only one node, then the 2 pointers first and the last points to the single node. So I will just repeat it again. In the first iteration, if I'm inserting only one node, for the first time I'm inserting the first node, then the first and last pointer points to the first node. If I'm inserting the second node, then the first node points to the first and then second node points to the rear or last pointer. So this one is very important here. So we will see how to insert in code. For pop operation, simply we need to delete the first node, right? So we just need to make first equal to first dot next. So we call DQ in queue. Okay, in stack only we call it as a pop operation. In stack we remove the top element. In queue we just remove the first element. The only difference between stack and queue is in stack it uses LIFO, that is last in first out approach, and in queue it uses first in first out approach. Okay, apart from that, here we are using 2 pointers. In stack we used only one pointer, which is top. We used only top node, and in linked list we used only head node. But here in queue we are using two things, front or first or otherwise rear or last. I am going to use the name first or last. Okay, so in code I am going to use the name first or last. So how to implement? So totally we have operations like Enqueue, DQ and then peak in queue. So how to implement this entire operations in queue in code, we will see it next. So now we will see how to implement queue in code. So here I took a simple class. So as you can see here, I took a simple class. It doesn't have anything. So first of all, what we need? I already told that we need 2 pointers. We need 2 nodes, first and the last. I'm just creating these 2 nodes, first and then last. But what is first and last? First and last are node. For that I need to create a node class. So I'm creating a inner class which is node. So what is needed, or what contains a node? A node contains a data. A node contains a data and then pointer to the next node. Then pointer to the next node. For that I'm creating a constructor so that whatever data I'm sending to this constructor, it will get added to the node. So I'm just making it like this dot data. Yeah, so here I simply created 2 nodes, first and last, and then I created a node class. We already know that a node contains a data and then pointed to the next node, and I simply created a constructor so that whatever data I'm sending to this node, it will get added to the node. Okay, So first operation we are going to do is enqueue operation. So I'm writing a simple, I'm going to return a queue itself so that we can print this queue and see what are all the elements in this queue. So public queue, and then I'm naming this method as enqueue. I'm naming this method as enqueue. So we need two inputs. One thing is queue so that we can add the elements to this queue, and then the second argument is data. Okay, so here for the first time I don't know what to return, so I'm returning null. Okay, so the first step is we need to create a new node with the incoming data. So I'm creating a new node, with the data which I am having. This is the input data. So whatever data I'm getting it as an input, I'm just passing it to this node so that this data will get added to the node which is in the queue. Okay, so here I'm going to check two conditions. So first thing is, for the first time, for example, I'm going to insert the first node. In that condition, in that phase, last is equal to null. The first time, last equal to null, because we already I didn't even inserted any nodes here. So for the first time, so I will just write it here. For the first time, last is the node which I represented here. So if last equal to null, then I need to make last equal to new node. Need to make last equal to new node. As I already said, for the first time, first and the last points to the first node. Okay, and then else condition, if the last equal to not null, then it means that I'm already having elements in the queue. So I will just write here, for example, I'm inserting 1 for the first time, then it goes to this condition, if condition. Okay, if already I'm having nodes like 1, 2 is already there and I'm inserting newly 3, then it will just go to the else condition. Okay, so if I'm going to insert 3, then the last node is 2. So I need to make last dot next equal to new node. I'll just explain this one again. So I'm going to write this if else condition in a different way. So else condition means what? Last not equal to null. What is the else condition? If last equal to null, if it is else condition, then it means that last is not equal to null. So I'm going to write this part in one loop. So you can see here, what I'm going to do is, if last not equal to null, if last not equal to null, then I'm going to write this condition here, and then this one is the common one, so I'm going to write it here, and then I'm going to delete this one. Okay, same condition I have written in a different manner. Okay, and then I have to check one more condition, like if first is null, if first equal to null, then I'm making first equal to last. Okay, then I'm making first equal to last, and then I'm returning the queue. So I will just explain this one again. So I created a new node with the incoming data. If the last is null, then the new node which I created, I'm just assigning that new node to the last. If the last node is not null, if last node is not null means already I'm having some elements in the queue and I'm adding 3 as a new element, then it will go to the if condition, and then I'm making 2's next as 3, that is last element. So here in this condition, last element is 2, so I'm making last next, that is 2's next as the 3. The new node is 3 here. in this condition. Okay, so for the first time it will go to this one, and then it will just assign a new node to the last. For example, I'm inserting 1. I'm inserting 1. Then it create a new node with the data 1, and then last is not equal to null. So this condition fails. So it will go here, and then it just makes last as 1. Okay, for the first time, first is also null. So here first is also 1. Okay, second time 2 will come. Okay, second time 2 will come. In that case, it just creates the new node with the data 2, and then here last is not equal to null, because in last we are already having 1. So here in last we are already having 1. So last is not equal to null, which is 1. That's why it is going here. And then it just makes the last next as new node. So what is the new node here? 2. So it just makes, so last node is 1. It makes 2 as the next node. This is what happening here. Okay. And then again in this one, it just makes 2 as the last node. So that in the next iteration, when 3 comes, then 2 is the last node. Okay, it won't come here in the second iteration. I think you people can able to understand. So I'm just removing all those things. Okay, if you want, you can execute and you can see, you can make a breakpoint and then see what is happening in each step. That is really helpful. Okay, and then I'm going to print and show you what is happening exactly. So I'm writing a print method here. So for print, I'm not going to return anything. So I'm just print, and then I need a queue here. Okay. And then first thing is node. I'm just taking this current, and then I'm giving, need to make queue dot first. Okay. Then I'm going to make a loop. Check current not equal to null. Then I'm going to print elements in the queue, elements in queue, but current dot data. Okay, it is nothing but current dot data, and it has to go to the next element. So I'm making current equal to current dot next. Okay, and then I'm going to create a main method, which is, what is a main method? Main method is public static void main arguments, and then inside this main method I'm going to create a new queue, then I'm going to call these methods. So first thing is, first I need to enqueue all these elements. So I'm adding 1 here, so that the next elements are low. I'm inserting elements like 2, 3, then 4. So it has to maintain the insertion order. Okay, so queue has to maintain the insertion order, and the next thing is I'm going to print all those elements. See what happens. Just executing it. So here you can see it just uses the insertion order, which means that I inserted 1 as the first element, so 1 is at the first, second as the second element, and the second is at the second position, and obviously 3 at the third position and the 4 at the fourth position. So we inserted or enqueued the elements in the queue. Okay, so next we will see how to do peek, dequeue, and then whiter. So now we will see how to implement peek and dequeue method in queue. For that we need is empty method. We will see what we are going to do in this method. So I'm just creating one boolean method, and I'm calling this method as is empty. It's just going to check whether the queue is empty or not. It's going to check whether the queue is empty or not. For that For that, I'm going to check like if q dot first equal to null, then it has to return the first node is null, then it means that it doesn't contain any elements in that queue, or otherwise default condition is I'm just returning false. So it is a simple method which just checks whether the queue is empty or not. So if I check first element, if the first element itself is not there, which means that the entire queue is empty. And then we implement peek method. It is somewhat like a stack peek method. So public, I'm going to return integer here, and then I'm calling this method as peek method, and then we need inputs like queue. Here I'm going to check, first thing is I'm going to check this ins empty method. If the queue is empty, then we can't return any element, there is no top element, right? So in that case we have to throw the exception or new, yeah, or otherwise I'm going to get this element which is q dot first dot data, and then q dot first dot data, and then I'm going to return this. So now we will see how to implement dequeue method. I'm going to take it as a void method and then dequeue. Here also we need input, yeah. So I'm going to check the same condition which is present here. If it is empty, then it has to throw the no such element exception, and then I'm going to make q dot first equal to q dot first dot next, q dot first equal to q dot first dot next, and then I have to check like if first equal to null, then I have to make last also null. Yeah. So I implemented peek and dequeue method here. For that we need is empty, so we need to check before the operation we need to check whether the queue is empty or not. If it is queue, then we have to throw no such element exception, and then we are performing the desired operation. Like in stack we just take the top element, but in queue we are taking the first dot data. It is somewhat like queue stack only, okay. And then we will just print and check. Already we are having this main method for push. So what I'm going to do is I will just show here. So already I inserted Enqueue, already I inserted all those data, and then I printed the data. Now I'm going to get the peek data. For that I need to call this method peek of, I'm calling everything from a static method, so I have to make it this static method. I just need to make everything a static. Again I'm getting some error, okay. Just changing all the elements to static because I'm calling from a static method, so it can only access static variable, that's why we are getting this error, okay. And then after peek, so I'm going to print all those things, and then I'm going to call dequeue method, which is nothing but, and then again I'm going to print the data. So we'll just execute and check whether it is working or not. So here you can see first we pushed or otherwise we enqueued the elements in the queue, which is 1 2 3 4, and the peak data is 1. Peak data or otherwise first element in the queue is 1, and then after deletion elements in the queue are 2 3 and then 4. So after deletion the elements are 2 3 and then 4, so top element got deleted after dequeue, okay. I'll just explain this code again. So simply we created one queue class. Inside that I created one node, and then I just mentioned first and last node. So we know that a node contains a data and then pointed to the next element. So first process in this one is enqueue, which is somewhat like insertion at head, sorry, which is somewhat like insertion at tail in queue. So here we already explained the logic. So we created a new node. If the last node is null, then we need to make this new node as the last node. If the last node is not null, which means that the queue, if the queue already contains the data, then we need to make the new node as the last node next. For the first time, first node is null. So for the first time, we are making the first equal to last. Okay, and then we are printing all those things. And then for peek and dequeue, we need this is empty method. So it just checks whether the queue is null or not, which queue contains data or not. And then it just we are just checking this one. If it is empty, then it has to throw the no such element exception. And then peek, so it just returns the first data in the queue. And then in dequeue, again we are doing the same thing, and then we are making q dot first equal to q dot first dot next. So simply we are making first equal to first dot next, which means that the first element got deleted. Okay, if first is null, then we are making the last is also null. Okay, so this is what is happening. So you can get my code in my GitHub account. I will just mention my GitHub account in the comment box. And then apart from that, yeah, if you have any doubts, please mention in the comment section. Thank you, and have a nice day.